Welcome back to Now, That's Interesting. Today, we're diving into the fascinating world of nuclear power stations, how they work, and how these massive structures are built. Nuclear power has been around for decades, generating electricity for millions. But how does it all come together? Don't forget to like and subscribe, and let's find out. Nuclear power stations are engineering marvels that harness the immense energy stored in atoms. The process starts with something called nuclear fission. But what is nuclear fission?
Nuclear fission is the process of splitting the nucleus of an atom, usually uranium-235. When the nucleus splits, it releases an enormous amount of energy in the form of heat. This heat is used to create steam, which spins turbines to generate electricity.
A nuclear power station has three key parts: the reactor core, where fission happens, the steam generator or heat exchanger, and the turbine generator, which turns mechanical energy into electricity.
The reactor core is where the uranium fuel rods are housed. Neutrons are fired at the uranium atoms to start the fission chain reaction. Surrounding the core is a coolant, often water, that absorbs the heat. This hot water turns into steam in the heat exchanger, spinning the turbines.
And how do we keep something as powerful as nuclear fission safe?
Safety is built into every step. The reactor core is enclosed in a thick steel and concrete containment structure. There are also control rods made of materials like boron or cadmium that can absorb neutrons and stop the fission reaction if needed. Plus, multiple backup systems ensure cooling in case of an emergency.
That's how a nuclear power station works. But how are these incredible structures built? Let's take a closer look at the construction process. Building a nuclear power station is no small feat. It takes years of planning and construction. It all starts with the perfect location, somewhere geologically stable, near a water source for cooling, and far from population centers. The first step is laying a massive foundation to support the heavy reactor and cooling systems. Then comes the reactor building itself, with layers of reinforced concrete and steel to withstand extreme conditions.
Every layer of the reactor building is inspected multiple times to ensure it meets strict safety standards. It's like building a fortress.
The reactor core and steam generator are then carefully installed. These components are often built off-site in factories with precise engineering. Once they're in place, miles of pipes and wires are added to connect everything.
One of the most complex parts is the cooling system. Nuclear reactors generate enormous amounts of heat, so we need cooling towers to manage it. The water is cycled through the system, cooled and reused, with minimal impact on the environment.
After construction, the plant goes through rigorous testing before it starts operating. Every valve, wire, and bolt is checked to make sure it's ready to generate power safely. Today, nuclear power provides about 10% of the world's electricity. It's a clean energy source, producing no greenhouse gas emissions during operation.
Of course, there are challenges like handling nuclear waste and ensuring plants are decommissioned safely at the end of their life. But with advancements in technology, nuclear power is becoming safer and more efficient.
So there you have it, the science and engineering behind nuclear power stations. From splitting atoms to spinning turbines, it's a powerful reminder of what humans can achieve with knowledge and innovation. If you found this as fascinating as we did, hit the like button and subscribe for more episodes of Now That's Interesting. Thanks for watching, and we'll see you next time.